Hello everyone, welcome to 30 Days of CNCF Project. Today it's with me, Engin, and I would like to kick off day 14 and introduce you to Strimzi, one of the interesting CNCF projects that I'm sure you will find is also very interesting after this session. And yes, that's the agenda for today. So obviously we're going to talk a lot about Strimzi and how it works. And to end up the presentation, I would like to give you also a little demo and show you how Strimzi is working in action. So after all, you should have relatively good understanding and start from here to dig deeper and see if Strimzi could help you for your next project or for your current project where you're looking for some of the features Strimzi has to offer. So let's see and dive into it. So, first of all, it's very important to mention that Strimzi is an open source project. Yes, of course, very obviously we are part of the 30 Days of CNCF project. So, as the other projects we're going to present here in this series, Strimzi is also part of the CNCF landscape, CNCF project landscape. So, you can use it without having any hesitation on if there will be soon a license change or something like this, because we saw what happens in the past when tools we are using have some very invasive license changes and you're completely committed to this piece of technology and you come to a situation like, okay, how is going the license change affecting me? What kind of business I'm working? I am violating some kind of conditions defined in the license. So here, as mentioned before, Strimzi, part of the CNCF project, so don't need to worry about this. And as you can see, one of the main goals, and we come also already to the content of Strimzi, is to simplify the process of running Apache Kafka, and with a little plot twist here, running Apache Kafka on Kubernetes. I worked before with Strimzi, I worked before with Apache Kafka. So first time when the development team reached out for me and started to investigate some kind of event-driven architecture, they're like, hey, Engin, we need a system like Kafka where we can create our topics and then communicate with our different microservices. So at this point, all we had was Docker. So we had several Linux servers and I installed Docker Swarm on it and then installed Apache Kafka and at this time also Zookeeper. And you can imagine it was really, from an operational perspective, it was really archaic. I mean, this time was a lot of manual stuff. So connecting into the container, executing here the Kafka CLI to create topics was really time consuming, was really something I could not fully automate and I just didn't like it. So when we later in the company switched to large OpenShift clusters, we also had then access to Strimzi. So it was the first time I got in contact with Strimzi. And I'm not 100% sure if it had the full functionality it has now, but I still remember it was a completely different experience and different feeling than I had before on my Docker system. So I was really in love with Strimzi and it really helped me here to create my brokers and provide the service to the customers because they also moved to OpenShift. So even the communication between the Kafka brokers and the applications was very cool. So I really, as you can see, love Strimzi a lot. And highlighted here, which is also very important for me for this session, is I would like to also talk a little bit about the basics of Apache Kafka. It's not going to be a full overview, so I'm not going into every tools inside the whole Apache Kafka ecosystem, but it should you give a good understanding, and then you can also map this to what Strimzi is offering, and then you get the connection like, okay, that's a topic, and for this reason we have a topic operator also in Strimzi, and that's the way I'm going to define the topic here. So very interesting. With this, let's go into some of the details. So Strimzi has a flexible configuration we can use to meet our needs. And that's very important for me because nothing is more annoying when you work in a project when you have to adapt yourself to the tool. This can be, yes, of course, you need to adapt yourself a little bit to the tool because that's the reason you chose the tool. But then sometimes some tools really go very deep and say, okay, you have to be in this way and you have to follow these instructions. So that's something I'm not liking very much. But here with Strimzi, we have the possibility to really configure the Kafka system to our needs. We can set up from some sizes of topics to how we're going to run the different brokers. So, for example, for production deployments, we can spread the Kafka brokers across multiple availability zones using reg awareness and ensuring better fault tolerance. So we see we have everything in place to create production-ready deployments of our Strimzi system, of our Kafka system with multiple Kafka brokers. And here comes also a very interesting part is that we can set up, for example, Kubernetes taints and toleration to reserve dedicated node for Kafka. So we eliminate some kind of noisy neighbor scenarios where maybe some applications or some programs running on the specific cluster take up all the resources and maybe threaten your operational stability of your Kafka cluster. So in this case, you can really say these clusters are dedicated for Strimzi, and everything is possible to set up. That's also nice. So the person, the team, the project team behind Strimzi really thought about this kind of details. Before we dive too deep into some of the parts of Strimzi, let's take a second and talk a little bit about Apache Kafka. Apache Kafka was created around 2008 at LinkedIn. Here you see the persons behind this. So Jay, Neha, and June are the masterminds behind Apache Kafka. And they created around 2008 Apache Kafka to meet the demands of LinkedIn at that time. So LinkedIn had millions of messages going on, millions of logs, which has to be processed. And they come to a place where they hit the limits with their existing systems. So it was time for them to think about a system which can handle this high volume of log processing better. And this is the moment Apache Kafka was born. And I think all three of them later started also left LinkedIn shortly after because they realized the potential of Apache Kafka and they created their own company called Confluent. And Confluent is for all things on the commercial side. So if you ever have a need to run Apache Kafka and you need some kind of commercial support, then I think you will find also Confluent and see what they have to offer. Okay, so here in this picture, you're going to see a typical organization before the introduction of Apache Kafka. So you see on the top, you see multiple sources, source system which generates the data, and then think about the data having different data formats. And then you have to think about the data integration, combining this data from multiple sources into one unified view for the business needs. So typical thing, a business is going to collect the data through different applications, accounting, billing, CRM, websites, and so on and so on. Each of these applications have their own process for data input and update. In order to get a unified view of the business, engineers have to develop bespoke integrations between these different applications. And these integrations can result in a complicated solution, as you can see in the picture, like communicating with the target system. Each integration comes with its own difficulties around the protocol they are using. So some applications they're using TCP, other ones using HTTP, FTP, HTTPC. So there's a lot of different protocols here. And then you have also different data formats. So some applications parse the data as a CSV, as a JSON, so you can see, think about also about the applications you may encounter and how they handle and communicate with data. And then last but not least, we have also the situation of the data schema and evolution, how the data is shaped and may change in the future if there's some new properties going to get added to the data or properties deprecate or gets removed. So again, here the whole data schema and evolution is a challenge on its own. So here's now the point where we introduce Apache Kafka. Apache Kafka allows us now to decouple the data streams from the system. So as you can see on the diagram, putting Apache Kafka in the middle and using Apache Kafka as a data integration layer, data sources on the top will publish the data to Apache Kafka, and the target system you see on the bottom, they will source the data now from Apache Kafka. This decouples the source data streams and the target system and allows us now for a simplified data integration solution. The use cases of Apache Kafka are really many. So they include streaming processing for different business applications, messaging systems, activity tracker, gathering metrics from different locations, for example, IoT devices, application log analysis, decoupling of system dependencies, integrating big data technologies like Spark, Flink, Hadoop, and event sourcing store. And this is what I also mentioned before. So I worked also in my former place in a production facility, and we had plenty of IoT devices, and they also created on a huge amount of data points which has to be collected. So using Apache Kafka was very nice for us to handle this huge amount of data points generated from the different IoT devices. And then of course on the classical application side, event sourcing was also a very valid use case, and people use this, and the whole microservice architecture, for example, worked on this concept, creating here large Kafka topics where the different applications could listen to and then react on this one depending on what they're going to achieve. Okay, let's talk about some of the, I called it here anatomy of Apache Kafka, but some of the terms folks use in Apache Kafka and what does it mean. So, okay, first thing to talk is about message. So think about that's Kafka's unit of data. And you can think about it, it's similar to a row or a record from the database world. So a message can have optional piece of metadata called key. Internally, the message and the key are just arrays of byte. The key, just the use case for the key is that it can be used, for example, if you want to have more control in the partitioning of the message. So, for example, Kafka can guarantee you that a message with the same key will be placed on the same partition using consistent hashing in the background. A message stored in Kafka doesn't have an explicit message ID. Instead, each message is addressed by its logical offset. This avoids the overhead of maintaining index structures that map the message ID to the actual message location. And to compute the offset of the following message, the consumer has to add the length of the current message to its offset. Next one are topics and partitions. So messages in Kafka are organized into topics, and think about topics like tables in a database system. A topic itself can be split into multiple partitions. Partitions are the way that Kafka offers redundancy and scalability. The partition can be hosted on a different server, meaning a topic can be scaled horizontally across multiple servers. Each partition of a topic corresponds to a logical log. Physically, a log is implemented as a set of segment files of approximately the same size, for example 1 or 2 gigabyte. Whenever a message is written to the partition, the broker appends the message to the last segment file. Now, the next one is producers. So, the clients who publish the message to the topic are called producers. The producers will write the message to a particular partition. This is done using the message key and a partitioner to generate a hash of the key and map it to a specific partition. By default, the producer will evenly balance the message to all topic partitions. In some cases, the producer can direct message to specific partitions. This is achieved by applying a specific partition scheme on the message key. Next one are consumers. The clients read the message by pulling it from one or more subscribed topics. The consumer will read the message in the order they were written in the partition. The consumer tracks its consumption using the manage message offset. If the consumer acknowledges a particular message offset, it implies that the consumer has received all messages before that offset in that partition. Consumers work as part of the consumer group, one or more consumers working together to consume a topic. The group is designed to ensure that only consumers will be responsible for each partition. As you can see here from the example, and if we look into more details here in this, you will see there's a message topic with 4 partitions, partition 0, 1, 2, and 3. And consumer groups having 3 consumers, consumer 0, 1, and 2. A possible mapping partitions consumer is consumer 0 with partition 0, consumer 1 with partition 1 and 2, and consumer 2 with partition 3. Let's talk about the architecture now. So we talked about a message, topic, and partition, consumer and producer. So that's one part. Now we can see how it works inside a cluster. So inside a cluster we have a broker. The published messages are stored at a set of servers called brokers. The broker receives messages from producers, assign offset, and write them to disk. It also serves consumers by responding to the message fetch request. And all of these brokers are then organized here in a cluster. So one broker will act as the cluster controller within the cluster. The controller is responsible for administration operations. In Kafka, replication provides redundancy of message in the partition such that one of the followers can take over the leadership if one of the brokers fail. All producers must connect to the leader to publish a message, but consumers may fetch from either the leader or one of the followers inside the cluster. There's a single broker in the cluster who owns a partition. This broker is called the partitions leader. Replicated partitions are assigned to additional brokers called followers of the partition. And as we can see here on the architecture, typically consists, a Kafka cluster typically consists of multiple brokers. To balance the load, a topic is divided into various partitions, and each broker stores one or more of those partitions. Numerous producers and consumers can now publish and retrieve message at the same time, makes it highly available. Okay, before we go back to Strimzi, let's talk about some of the companies using Apache Kafka. And I looked around to find an example of a large company, of some newer use cases of folks using Apache Kafka. And I stumbled over this article stating that Tesla is using Kubernetes and Kafka to handle trillions of events per day, which is really, really awesome. So I put the link down here on the slide, and you can have a look into this and see how Kafka is enabling Tesla for handling all the events. With this said, let's go back to Strimzi. So we discovered now some of the details of Kafka. We saw the combination between message, topics, partitions, brokers, consumers, producers, and then the whole setting up the brokers in a specific Kafka cluster. So now we come to the point where Strimzi is shining. So Strimzi provides here now container images and operators for running Kafka on Kubernetes. And the operators are specifically designed for handling all the operational knowledge we need to run and manage Kafka on Kubernetes. So what does Strimzi simplifies for us here? So Strimzi operators are deploying and running for us the Kafka clusters, deploying and managing the different Kafka components for us, configuring Kafka access, securing the Kafka access, also taking care of some of the day 2 operations like upgrading Kafka, managing all the brokers for us, and now also the interesting parts, which may be very interesting if you're going to some kind of platform engineering journey and want to provide, for example, a golden path for your development teams. It's also handling the creation and the managing of topics, and also the creation of managing users, which was, as I mentioned before, on our Docker Swarm clusters, very operational effort to handle all this kind of stuff, and something which was very difficult to automate and required a lot of self-written scripts we had to provide via Jenkins, for example. So here already a plus point. Now we can see the Kafka component architecture here by Strimzi. So we have in the different parts of Kafka which Strimzi is offering here. So we have Kafka Connect, which is an integration tool for streaming data between Kafka brokers and other systems using this concept of connector plugins. I'm not going into details of this because this is a huge chapter on its own. When we introduced Kafka in my former place, Kafka Connect was really a good, interesting use case for the developers. And they're like, okay, we could even replace some of our microservices by creating a dedicated Kafka connector. And that was also interesting. So please have a look into Kafka Connect. So, because it provides here the framework for connecting Kafka with external systems. Okay. Heading over to the Kafka Mirror Maker. So with a Kafka Mirror Maker, we have now a tool in hand to replicate data between two Kafka clusters, either in the same data center or across different locations. Kafka Bridge. Kafka Bridge provides us an API for integrating HTTP-based clients with a Kafka cluster. So not all the clients or all the programming language or all the situation, you can use an SDK in your dedicated programming language. So sometimes it's useful to go the HTTP way, and then you could use Kafka Bridge to provide here access to your Kafka cluster. Kafka Exporter, also very interesting here for our whole observability part, is extracts data for analysis as Prometheus metrics, primarily data relating to offset, consumer group, consumer lag, and topics. Zookeeper, this is optional because it's not necessary anymore in newer Kafka versions and newer Kafka architectures to use Zookeeper. So there is a concept with Raft where they find out the who's the leader and can reasoning in their own cluster, so you don't need this anymore. But if it's still necessary, Strimzi offers also this. So the Zookeeper provides cluster coordinating, storing, and tracking the status. But again, it's not necessary anymore nowadays with the instruction of Craft. You no longer need Zookeeper to handle the cluster coordination. As I mentioned several times, Strimzi, the Strimzi project, highly leveraged the power of Kubernetes operators. You may or may not encountered already operators, but to give you some short background here, operators are a method of packaging, deploying, and managing Kubernetes applications, and they provide a way to extend the Kubernetes API. And here comes the point: simplify the administrational task because it takes over some of the work we would do as a human. Just talked before what I did on this very basic Kafka cluster I had to operate on Docker. So Strimzi operators, they support tasks like the Kafka deployment itself, and we have also the way to provide some detailed deployment configurations. For example, how many clusters we would like to have, some cluster related configuration, topics, users, and other components like Kafka Connect and so on. Then yes, with this defining of the custom resources, as you can see on the right side, we have now the situation that the Strimzi operator knows exactly how and what to do within the Kubernetes environment. And with this, it really takes care to reduce all the manual work I had to do in case of all the operation you normally do around your Kafka clusters, for example, managing and updating the Kafka cluster. What operators are included in Strimzi? So on the right side, you see the cluster operator. This is very, very important for deploying and managing your Apache Kafka clusters, and also deploying the additional tools like Kafka Connect, Mirror Maker, Bridge, and so on and so on. And it also deploys the entity operator. And the entity operator, which is funny, also comprises of two different operators itself. So first of all, we have here the topic operator and the user operator. And obviously the topic operator takes care of all the things related to a topic, and the user operator also related to a specific Kafka user. You can also connect them to your SAML, for example. You can use technical users. As you can see, many options are there. And it's time for the demo. So let's head over and see the demo. Let's start with the demo. For this case, I created a Kubernetes cluster here locally using kind. You can of course use any Kubernetes cluster you have on your site, like using one of the cloud providers or using Docker Desktop. It's completely up to you. So I created here a kind cluster version 1.32. Everything is set up, nothing is installed. Let's have a look into the Kubernetes cluster. So it's completely vanilla, no additional applications is installed. And now I'm going to install the Strimzi cluster operator. And as you can see, I'm using here an OCI artifact where the Helm chart is inside. So I don't need to set up a Helm repo add and putting a HTTP address of the Helm files and not doing a Helm update and so on. So that's very cool because here I'm leveraging container registries to deploy an OCI artifact containing our Helm charts. Going to create a namespace called Strimzi and say the operator to watch any namespaces. You can also set some namespaces to avoid to create the cluster here with cluster rights. Okay, so let's install this, and this should go pretty quickly. Pulling down, yeah, everything is installed. Let's have a look into our cluster. Again, I'm using K9S, and we can see it's going to download now the operator here. In this case, I'm using the latest version 0.45, and hopefully in a short time everything should be up and running. Yes, the operator is up and running and we are ready to continue. So waiting a couple of seconds until it's ready to use. So, okay, let's head out of K9S, and we can also use here kubectl commands if you prefer this over K9S, for example, and we can see here that now it's ready. Perfect. So let's continue. Let's create our first node pool. So to do this, I created here now the command. So as you can see, we're going to use here kubectl to apply here this manifest. So I'm going to create a Kafka node pool, name it my Kafka node pool. Very creative. And then we also label it here with the Strimzi.io cluster annotation to say, okay, this node pool belongs to the cluster, my cluster. We're going to create this. And here you see the roles we're going to assign to this node pool. So here it's controller and broker. And I'm not using any storage here because it's for demo purposes, but you can also then define the storage if you have a persistent storage here. In this case, I'm using an ephemeral. So head into our K9S to see if it's up and running. And we should see then Kafka node pool. We should see here it's not deployed, but it's registered, the CRD. And now we can continue. Yep. So let's head out of it, and then we're going to create our first cluster. So here is the cluster definition. Let's have a look into this one also. So let's head over to the top, and again using here the Kafka CRD, telling here we want to use craft. So we don't want to use a zookeeper, so craft should be enabled. And it should use node pools. This is also enabled using here the annotations. And then I can define some details around our Kafka broker. So the replicas is 1, a specific Kafka version. Again, I'm using here ephemeral storage. I'm defining the version of the Kafka, the ports for the listener. That's all here. And then some config around Kafka, like the offset topic replication and so on. What we are not going here to configure and use vanilla is the topic operator and the user operator. So, but again, you can also define some specific properties there. Okay, this one is also created, and now we can have a look into our cluster, and we see that the image gets pulled for this specific Kafka version we would like to deploy, and yeah, perfectly fine. It's also starting, so this is also cool. So our cluster is soon up and running. So we can also, if you not like to use K9s, we can also go here with the kubectl commands, and then we can set with -w to wait, and we see that now everything gets deployed. We see now the Kafka entity operator is also up and running. I just mentioned this there, taking care of creating the topics and the users. So let's head out of this. And now we're going to create our first topic. So here, using the Kafka topic, custom resource, and then saying on which cluster this Kafka topic should be created here, in this case to the created Kafka, to the my cluster one I just created before. Some configs again around the topic, like for example, how many partitions I would like to create, how many replicas, here in this case 1 and 5, retention time and so on. So that's all details around Kafka. And now the topic is created. And to see a little bit more, I would like also to use here a specific Kafka UI to give you also a little bit more the visual feedback. So I'm using Kafka UI. I like this UI tool very much. And for this one, we're also using Helm. So I'm going to create here the values YAML and point in some of the properties. So here the name of the Kafka cluster, and then the Bootstrap server, and this it's the internal service of the Kafka cluster, just the port 1992 we just defined before, and then not using any authentication. Again, don't use this in production. So saving the values, and now we can add the Kafka UI repo and update here the Helm charts, the repositories, and now we can deploy the UI. Okay, so the UI is also deployed, and let's have a look how the UI looks like. So I'm opening a second window, doing the port forward, and opening here a window, and then navigating to localhost 8080. And then we can see here our UI is up and running and gives us some more information. Let's go to the dark mode, and then we see my cluster is up and running. We have here the brokers, how many partitions are on the broker, some details around this. Of course, we see our topic, again, the partitions. We can also look if there are some message. No, there are currently no message and no consumer, so that's completely fine. So let's give it a try and create a little bit some messages on it. So for this, again, I head back to my main screen where I installed the Kafka, and then I'm using here the kubectl run command to connect to run an image, here in this case of a Kafka image, which will then use the address of the Bootstrap broker to create some message. So let's connect to it, and this should work hopefully very good. So let's see. normally this should run fine. Let's have a look into K9. Ah, yeah, there's it. So now we have our prompt, and we can enter here hello world and say, oh, okay, now it's hello world and hello world 2. Okay. So let's have a look into our UI. We can see there's already message here. I already partially entered some message here because it didn't recognize the D here, and everything is up and running. So now let's also open another window and create a consumer to see how it works. If we would like to simulate that a consumer is listening to a specific topic. So again, creating here the Kafka consumer. So pressing enter, and now let me put the windows here, and we say test consumer. So the consumer already gets all the existing one. We mentioned this before. It will read through all the topics to the point where it's waits for a new message. Here in this case, I'm creating now a new message called test. Let's call it test the consumer. And now we should see test the consumer, and continuing for that hello world and hello world here, and then also the message here, hello world, test the consumer, everything is up and running. We see the consumer which is listening, so it's also registered active consumers. That's very, very cool. Okay. So yeah, and that's it. If you want to destroy everything, of course, you can just delete the Helm release or destroy the whole cluster. And yeah, that's it. That's all about Strimzi. I mean, of course, not all. You will see when you dig into documentation that there are plenty of configuration parameters. And as I mentioned before, we did not talk about Mirror Maker. We did not talk about the huge chapter about Kafka Connect, which is our own world on its own. And we also didn't talk about the whole Kafka schema registry, where you can register your schemas, and that's really a thing on its own. But from an operational perspective and from running Kafka on Kubernetes, you saw that Strimzi is offering here really an easy way to quickly bootstrap a Kafka cluster, be it for development environment or bootstrapping a Kafka cluster for production environments, and then having with, for example, Kafka replica, you can then replicate the cluster informations between different environments, for example, providing some informations for a pre-production stage or for development stage if you want to try to replicate a specific use case. Again, big topic, and I hope you liked it so far, and please stay tuned for the next CNCF project we're going to present here. And with this, thanks for watching the introduction, and looking forward, and see you soon. Bye.